So let's look at our playground. In here, I've created a new class called person. Person gets initialized with the name. And when it's initialized, we print out name, that thing right there. And then when it's deinitialized, it prints out this person has been deinitialized. So let's run this and see what happens. Nice. What happened based on our printouts there? The initializer works. I also think the deinitializer works. We just never called it. When is this thing going to get deinitialized? Very good question. I could try to find a function called dinit, but it's not there. I guess it's not available to me. If I set it to nil, is that going to work? No, it's not going to work. So how can I actually deinitialize something in memory? Let's try some other things. What do you think? What's that? Do I have to initialize the deinitializer? Tell me more. Damn. But I want to hear more. So you can't set it to nil because it's not optional, right? Can't do that. It's not how this strongly typed language works. Let's see. Try to talk to my friends. I've got a certain search term that I have in mind. How to deinit Swift. Deinitializer. The deinitializer is called immediately before a class instance is deallocated. Okay, that makes sense. It automatically deallocates your instances when they are no longer needed to free up resources. Okay, so Swift handles the memory management of instances through ARC. Typically, you don't need to perform manual cleanup when your instances are deallocated. Okay, now they're trying to tell us some stuff more than I'm really interested in. I just want to know how to get rid of it. They're called automatically just before instance deallocation takes place. So, how to instance deallocation Swift. Instance deallocated. Interesting. Let's go into the same documentation. So maybe I should keep reading some more. Deinitializers in action. Oh, nice. So here's a class called bank. It manages a made-up currency. It's got a function that does some stuff. I want to see where they deinitialized it. So I'm getting lazy and I'm rolling past all this stuff. Damn, I guess not. The bank keeps track of the current number of coins it will hold in its coins in bank property. Makes sense. It also offers two methods, distribute and receive, to handle the distribution and collection of coins. Distribute checks that there are enough coins in the bank before distributing them. If there are not, it returns a smaller amount than the number that was requested. I don't see anything about deallocating. This is getting to be annoying. How are they going to be deallocated? I don't know. There's another class. Interesting. This class is another person that has coins, and they interact with a bank. Interesting. The bank has some static functions. Interesting. What's going on here? Oh, a player, which is an optional player, starts with some coins. They win. They distribute. They're doing some stuff here. No player instance. So I could literally set an optional to nil. Have we done that before? Plenty of times, right? All right. Let's see. If I made this person, here's an annoying way to do it. If I just said it is going to be an optional person and didn't give an initial value, I could then set the value of favorite person. Let's see what happens here. All right. So again, there's no initialization on this line. There is on this line because we're creating a person and we are saving that value to this variable. And this is super important because this is the thing getting initialized in memory. This is a place that that value, or this is a place that now is pointing to that thing in memory. Those are different. When I create a person, it doesn't just exist nowhere. And it doesn't just exist in favorite person. It's its own point. Weird, huh? Now if I said it's nil, and I run it, it's de-initializing this person. All favorite person is it's pointing to that specific place in memory. That's all it's doing. That's it. Michelle. That's a great point. Is it still a strong reference? Yes, it is, but it's letting us get around certain problems we'd run into if it wasn't optional. So the question there was, is this a strong reference? What's a strong reference, though? Do you have a definition? Okay. So by default, everything you create that's a reference type is a strong reference. So what is a strong reference, you keep asking? Anyone want to ask? Marielle, ask me.
What is a strong reference?
Thank you. A strong reference is a reference to an object that ARC immediately creates. So our reference counting immediately creates a reference to this object. But it might be the case that in the future, that reference might be unnecessary. It might keep stuff in memory. So not everything is a strong reference. Let me ask that question back to you. Nima. So a strong reference gets saved into memory and increases the automatic reference count. So if I declare a variable and I say fab p equal to something called p, and then I say new p for whatever these things are, it's also equal to p. P is saved here. Fab p is there. New p is there. And how many references are there in total? How many things can you refer to talk about that same value? What are the two? Okay. Could you also use P? Okay. Yeah. So in total, you've got 3 references to the same thing. So when you use a strong reference type, you're automatically creating a reference, and you are automatically increasing ARC to be 3. So let's do that. No, it's 3 because ultimately three different things or three different ways of referring to a specific thing exist. So there could be a reference to P. We initialized P in here, that's why I've put that value there. But when we go and try to use that variable, we are referring to that spot in memory. So this is just really some stuff.
So you just have P of A, P or P and stuff, or A, P and stuff, and you your ARC 2, not 1.
Ask that again. So I'm not, this stuff, I'm just saying that's the memory stuff. That's not actually a reference.
You have A, P, and this P, then your ARC 2.
Just literally think of it, automatic reference counting is how many different ways can you refer to the same stuff? Like, these variables exist for you to be able to refer to something saved somewhere. That's all reference counting is. But let's say we've got, I don't know, some new person, which is equal to favorite person. And then favorite person is set to nil. I guess I should make that a var. Playground cannot continue because it couldn't successfully compile. Aha. So, I have a new thing referring to favorite person. Even though I got rid of this reference to favorite person, there's still another reference called new P. So what didn't happen there when I set favorite person to nil? Ayla. Based on what prints out, what didn't happen? Yeah. What function didn't get called there? D-init never happened. That thing still exists in memory somewhere. Now, if I try to print favorite person, I'm going to get nil. But what's actually saved in memory still is there. I can now say favorite person is equal to new person. Then print it again. It's nil here. And then here, it's getting back a value that is a person. And this whole junk is just the way that Playground evaluates custom types that you create, blah, 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 who cares? But these are still getting their values from that same place that things are saved. So anything saved to that person exists here. Whoa, right? Whoa. All right, what if I don't want to do that? What if I don't want everything to just be referring to that? What if I don't want to be counting my references? So now here I've added back a fat P. 2. Update that. Check this out. Ready? If I make this new person a weak var, what does that do, you say? Doesn't look like it does anything. Does anyone know what I just did, though? It doesn't add it to the reference count. Dang, that sucks. Why do you think that is? Say that again? It's a little different. I would think of it kind of like an optional. Its reference to that place in memory doesn't exist until it needs to use that place in memory. So its reference is to favorite person, so to that same spot with all that stuff. But the ARC right here is 1. So it doesn't need to use that stuff. Which means that this looks like it's working the same way because, check it out. When we were doing this here, sorry, I hadn't run it before to show you the difference, and I apologize. When this variable was strong, there was a reference directly from that new person to wherever that stuff is. But now that it's weak, and the ARC is only 1, when I de-initialize favorite person, which has a strong reference type, ARC is 0, and so new person becomes 0. This is literally a counter, right? Like this is some number somewhere, just like we've used var counter sometimes. This gets increased every time there's a strong reference type to something in memory. And it gets taken away whenever you deallocate something with a strong reference type to that thing in memory. It does not get increased when you have a weak reference type, like that guy. And so if you remove all these strong reference types, that ARC goes down to 0, and that's how your memory manager knows to get rid of that, clean out that space in memory, get rid of that garbage. So it's called garbage collection in code. It's, really creative in how they came up with that name.
So that's why those outlets are weak in the view, in order for it not to take up so much memory allocation?
Tell me more.
That's all I'm going to say.
Okay. So the question was, is that why outlets are weak? And it's kind of yes. It's also because they might crash your app if you try to refer to them before they actually exist, because those outlets are from your storyboard to some other file saved somewhere. So if that file never ever saves, if that was a strong reference, you'd have a strong reference to something that's never been initialized. Because it's actually initialized in whatever interface builder does to create that storyboard file. That's where the strong reference is created. The outlet is just a reference to that. And so if that reference was strong, then the thing would have never been made in the first place. You literally never initialized a UI label, for example. And that's why those references are weak. B. Should we make some more things? All right. Are you guys all still alive? I don't know. What do you want to make? I want to show you one more thing. Ow. Check this out. This guy's weak. It means it doesn't increase ARC. It means it doesn't strongly refer directly to the spot in memory. That means it needs to get that information from somewhere else. So if I print it out, new person here, I run it, run. Doesn't know what to do. It's optional. If I unwrap it, it's a person. Hang on one sec. Okay. Got our person, got our weak person. Sorry, I'm trying to turn my brain on. Does anyone know how to do that? Right, that's nil, that's optional. No, be allocated. Person. That's nil. That's a weak reference. Oh, I can explain it and I can't code it. That's kind of terrible. Let's try this out. I want to show you one more thing because you will see it in the future. And then I want to try to make it work. Okay. We've got an unowned reference. Say I make this a weak var, make that a var. Is that going to do what I want? No. This will be immediately deallocated because variable favorite person is weak. Jason, can you tell me what that note there is about? I've got a warning right here about this instance. So there's no strong reference type. The ARC is 0 when I'm trying to use this thing. So it's immediately popped out of memory. So let's see, if I try to use favorite person. Favorite person. In optional person. That's a person. Let's see. Name. Optional Otis Redenbacher. Neat. All right. This object itself, this person, okay. Sorry, I'm having fun here. I hope you all are too. Thank you, I'm glad to hear it. That's nil. Expression implicitly coerced from person to any. Provided the default value to avoid this warning. Force unwrap the value to avoid this warning. Explicitly cast any as any. No, I don't want to do that. I don't want to make this optional. Oh man. Interesting. Damn, what's going on there? What's the error you see there? Any weak reference type has to be optional. Your strong reference type is the only thing that can be unwrapped. That unknown that we're going to get to in a second if my brain turns on won't. Mm-hmm. Oh no. What about that? Aha. Check this out though. It told us an error that didn't give us all the information. Just like with your outlets. So the error it told us is that a weak variable should be optional. But When we use the bang, we're implying that we are ourselves unwrapping an optional. That's weird, right? The bang is not a person. I'm sorry, person bang is not a person. Person bang is us saying, what we anticipate is this thing being optional, but we know it's going to be there, and that's why we're going to unwrap it. You're literally telling it that. And so that's why all your outlets are an optional, right? And that's why when you say have some kind of mess up with your link between outlets in the storyboard and outlets in your view controllers, that's why your app actually crashes, because you're trying to use a variable that doesn't actually exist in memory. Let's make that real quick. Beep, beep, real quick, outlet, crasher, app. Huh. Come on, computer. Real quick, outlet, crasher, app. Let's go. All right, so in my storyboard, I'm going to make a label. And then I'm going to have this label, create an outlet. Come on, buddy. Do it. Yeah. All right. So, if you notice, you have the option to make your outlets strong or weak. The reason they're weak by default is why, Phoenix. Why, when you create an outlet, which is a variable in a view controller. Like, let's think about that conceptually. An outlet is a variable only in that view controller. There's some matching thing in your storyboard and interface builder, but that variable is only in the context of this class, right? So by default, it tells you to make outlets weak. Why don't we want them to be strong? There'd still be yeah. And I think I heard in there a little bit, sorry. I think I heard in there that you might be referencing something that doesn't exist. I don't know, I heard that somewhere. So if I make this outlet for a label, by default we make it weak, but then it tries to unwrap it. So if I change the name of this variable to label1 and try to run it, this weak variable, going. This class is not key value coding compliant for the key label. So just to review something that I'm sure we've all seen 1,000 times, when it says this class is not key value coding compliant for the key label, where's that crash coming from? Is it coming from the view controller or the view? So it says view controller, but it's actually looking at the storyboard. It's looking for that thing called label, because there's nothing in here called label. But the connection between our view controller and our view is strong. What? Weird. The outlet itself is strong. The outlet isn't a variable that exists here or in the storyboard. but it's how they refer to each other. It's not magic. It's something that has to be saved, just like anything else. You have to tell the computer, this label is linked to this variable in the view controller. That's just generally a crash key.
No, right there.
Where you at?
The ID outlet. Right
Oh no, this is just the interface file for the view controller. But because it tries to refer to something that doesn't exist, it crashed. That's a strong outlet. I can't do anything about that here. But if I made this weak, come on, change. If I didn't make this weak, but rather made it strong, I said it's a UI label, and I looked at my storyboard, then I got rid of the label, what do you expect to happen? If there's no label, but there's a strong reference to a label somewhere. Let's see. Huh, interesting. Doesn't even let me. Because a strong reference, Xcode goes and catches it and says, you've got a strong reference, but IB outlet is non-optional. So that outlet property, which is separate from, which is, yes, looking at this, but not saving the same space to this, is itself non-optional. And so the bang, which we've said forced unwraps things, it's actually the implicitly unwrapped optional, which means it thinks it's an optional and it unwraps it. Super important. What if I added a question mark? So there's a strong reference to a label. Notice we never initialize the label in our view controller. It's getting initialized by the storyboard somewhere, or so we thought. Let's make the background here blue just so we can see when it's actually launched. Blue. Pursuit blue. That's that shade. Neat. So, our strong reference was to something optional. We have seen this before. What is the value of UI label? It's getting initialized supposedly by the storyboard, but the outlet doesn't actually exist. So that label is nil. So if I went and I tried to run it, what do you expect to happen, Sam? If I'm forced unwrapping a nil. Why does it look fine? Because we never actually try to use that label. So the view controller never tries to do it, and this guy never gets updated. We never use that label. What about if I say label.text equal to please don't kill me. Oh no. We've seen this a million times. When we talk about automatic reference counting, what we're doing is a very similar thing, but this time talking about where those things are actually saved in memory. These things aren't optional when I create them as weak, but you can think of a weak reference as kind of optionally pointing to a place in memory. It says unexpectedly found nil while implicitly unwrapping an optional. This guy? The Sigabert. Sigabert. So let's go to our app delegate. I'll run it again to break it. Oh my God. There's a delegate for the entire application. Well, now I added a label. Ah, man. Let me update that. Are we all having a great time? So I tried to use an implicitly unwrap thing that was nil. You've seen this plenty of times. I didn't get the error you wanted. Let's see if we can make it later. This guy? Oh, you wanted to see this guy, not the thing in app delegate when you crash. This guy is the same as what I see down here. Yep. Let's see what happens if I make this guy weak. Oh no, what happened? So it's even a step before that. We're still talking about optionals here. We tried to unwrap something that doesn't exist. That's still in our problem with optionals. But the real difference is going to come in, hopefully, if I'm doing this right. Blah, blah, blah. I have a strong reference here to an optional label. And I can do this because by doing this optional chaining, I'm saying if the label exists, make its text this. That makes sense to me. But if it doesn't exist, it doesn't do anything. This guy is weak. What do you think's going to happen, Sam? Nothing. Okay. But this is annoying. But this also never gets allocated. Nothing gets allocated as that label. So, what did we not see? What? We didn't see please don't kill me. We also didn't really see any difference in how these things will appear in the UI. But their references matter, because that's what's going to crash our app. This guy is implicitly unwrapped. And later on we try to use him. I hope nothing happens, but it will. Oh wow. So I have a weak reference to a label. It didn't kill. No, that's why. Sorry. Ah, fuck. All right, here's the thing. Yeah. It's not connected to the storyboard. Can I be really honest with you all? I don't think this is that important for you right now, which is why I'm finding trouble integrating it. Let's do it Monday morning, but I want you to have the afternoon because I know a lot of you, well, saw a lot of you last night working on your projects the day it was due. I'd like you to get a start on that before the day it's due. We're assigning a new project today. Yeah, that's how it works. Honestly, like,